कर.
So good evening. Our topic is blockchain and homomorphic encryption based privacy preserving data aggregation model in smart grid. In smart grid technology and smart metering system have raised serious privacy concerns about the collection of customers' real-time energy usage behavior. The majority of existing techniques have high computational and communication costs and are still vulnerable to various security and privacy concerns. The this paper proposes a deep learning and homomorphic encryption-based privacy-preserving data aggregation model to mitigate the negative impact of the flash workload on the accuracy of prediction models. The proposed model is 80% more effective than the traditional approach in detecting smart meter manipulation, and computational cost is 20 to 80% less than existing technique. So now I will just tell the introduction about what are this term means. So smart grid is a system for provisioning the flow of electricity and operational information over a robust and unfailing communication network. And you will say what is data aggregation? Data aggregation is a process where raw data is gathered and expressed in a summary form for statistical analysis. And you may ask that what is homomorphic encryption? So it is a form of encryption with an additional evaluation capability for computing over encrypted data without access to secret key. And for blockchain is decentralized and immutable, transparent peer-to-peer system with append-only storage. The transaction in blockchain are permanently recorded in group called block, and hash is generated for security by using parent block hash and current timestamp and data. The researcher considers special mechanism for structuring multidimensional data and encrypt the structure using homomorphic Pylar crypto system technique. Now the second slide there is a high level view of the system, which is physical attack and network attack, software attack, and data security threats. Then in next slide, the related work regarding this topic. Numerous studies have been conducted related to cybersecurity in smart grid or microgrid. The author mainly classified different types of attack based on network types, which are home area network, wide area network, neighborhood area network. The author described the effects of such attacks in the domain of information security, specifically those related to data integrity, confidentiality, and availability, which are the three important CIA. Then on to the next slide, uh, the diagram is being given about the users and number of users and the blockchain connected with the server. The scheme used is halt, winters, and seasonal threat decomposition with the user's prediction method for privacy preserving capabilities, meaning the scheme is resilient to filter and true value attacks. A coalition attack was prevented with the help of distributed decryption and algemal homomorphic crypto system. And onto the next slide, we have the image about home area network, then aggregation provider, and about the power center, which are connected to the cloud storage and aggregation node. Then from now onwards, Venus will continue.
Hi, good evening. In the overview of this scheme, this model has three major components. First is the home area network with smart meters. second an aggregation provider, and third one is a power center for or grid provider. For first smart meter, uh, PCs deploy the smart meter in every home area network for recording the uses of electricity. So in the model, the symmetric homomorphic key is a confidential entity, and it is not revealed to any third party for authentication purpose. And second one is aggregation provider. The key responsibility of aggregation provider is to verify the collected data and perform data aggregation, after which it forwards the data to the PC, and it essentially acts as an pseudo identity for collection request for each smart meters. And third one is a power center. So the PC plays a vital role in distributing electricity to each home area network. From time to time, the electricity usage information is collected from smart meters to optimize the electricity distribution. And another responsibility of the PC is securing communications to verify the proper authentication process and session keys. Once the session key and authentication process are successfully verified, the system the symmetric homomorphic key is forwarded to the smart meters. And in attack model, this this model is designed with consideration of three attacks: collision attack, internal attack, and external attack. So in a collision attacks on encrypted data, the main goal is to search for two inputs that generate a similar hash value. In the internal attack, this attack is accomplished by one person or a group of people from the same organization. The technical users or skilled people from the organization use their computer system to initiate the attack, and then remove the evidence. And in external attack, someone from outside the organization try to breach the system through social media, hacking, or malicious software. And this is even more difficult to detect than an internal attack. So in a performance evaluation and security analysis, the aggregation and verification processes use the computational overhead in the AP module. Therefore, we first discuss the computational overhead of the proposed model. So the system took to eye the electricity data for the aggregation, and the main reason for the improvement is the blockchain used in our system and a proper authentication process. The two-way process of security at the user and cloud levels increase the robustness of the model. In a computational cost, the experiment result shows that this proposed model is more cost efficient than the other data aggregation schemes. The efficiency of the data aggregation techniques came from the adding some smart meters data, and the existing schemes used the bilinear pairing that makes the process more complicated, while this proposed scheme used the blockchain to eliminate the verification process with authentication at the time of initialization. That helps us optimize the computational cost in the proposed model. And the proposed model can deal with false data injection attacks, man in the middle attacks, and stem replay. In first attack, the malicious data are injected into the smart meters by the attackers, which produces bad data. In this proposed model, the reliability of the user is considered to avoid bad data. In man in the middle attack, the attacker tries to interfere in the communication of participants by pretending to be an original sender. This attack is handled by the authentication and blockchain mechanism. Uh, this model this model's communication overhead is higher than other techniques because of authentication and blockchain being used in the processes, and therefore overall performance of this model is superior to the other models. Conclusion. So in conclusion, a multi-tiered architecture is designed for the data aggregation process using blockchain and cloud computing. So the privacy of data is maintained by authenticity and integrity, and a two-way security model is provided at the user and cloud levels. So this helps to prevent internal and external attacks. Further, collected data from various home area networks are not directly applicable to the analysis. So low quality data is discarded or improved before being used in the analysis model for big data analysis, and secure and efficient data collection and pre-processing processes were also introduced, and the proposed model was evaluated based on performance and security analysis, which showed that the proposed BHDA model was 80% more effective than the traditional approach in smart meters manipulation detection, and further the computational cost of this trained model was 20% to 80% less than the existing techniques, and the proposed B, this the proposed BHDA scheme shows a significant improvement in performance and privacy preservation within minimal computational overhead for data aggregation in smart grids. And here are some references, and thank you.